All right, question number 4, the limit. So in this case, we have a piecewise function. I would recommend it kind of be helpful to know, the general idea of what's happening with this graph or what it's going to kind of look like. And therefore, then we can kind of go from there. So let's just kind of graph this. Let's graph these two functions, how they would look. So we have 1 equals 4x. Well, again, that has a y-intercept of 0, right? So 1, 2, 3, 4, and then over 1. So that graph kind of looks something like that. And then the other graph is the reciprocal function. Well, again, that has a coordinate point of 1, 1 and negative 1, 1. So that graph looks something like that. They don't look a lot like that. However, this is not at 1. This is supposed to actually be at 1/2, right? So it actually looks like, yeah, it's actually not too bad. I'm not really that far off, actually. So that's kind of silly. It's the same point. That's less than equal. That's 1 and greater than equal. I wonder why you would do it for that, but interesting question. Let's go ahead and, yeah, we can use this. So that's what the two graphs would look like on the same, but obviously that's not a function, right? So we need to understand, what this graph looks like from one to the other. Well, what's the best way to kind of explain this? Okay. All right, those are the two graphs on there, but let's kind of get back into what we have here. Here, let me do this. Okay, so I have the two graphs, but again, that's not a function, right? It doesn't pass the vertical line test. You can see they have same points. So rather than graphing 4x for the whole domain, we're going to restrict the domain, right? Kind of like in that problem for the domain restrictions. Now, this is defined for all x values, but now I have a domain restriction for x values only greater than or equal to 1/2. And actually, yeah, let's just use a different color. So now for greater than or equal to 1/2, if I were to plug in 1/2 here, right? If I was going to do 4 equals 1/2, that would equal 2. So this is graded for all values greater than or equal to 1/2. So that graph is going to look like, so if I plugged in 1/2 here, that'd give me 2, right? So you could say, so then at 1/2, right? Because that's half of 1, I'd be up to 2, and then I just continue that graph. That means the rest of the red graph is actually not part of the piecewise function. So I'm just going to erase it from there. Then the other one is the reciprocal function. Now the reciprocal function is for all x values greater than 1/2, less than 1/2. So, okay, that's going to be values less than 1/2. Well, you can see that, and when x is equal to 1/2, you can see that actually it's equal to 2 here. Again, kind of odd, right? So when you have 1 divided by 1/2, that's also going to equal 2. But again, remember that's undefined here. So that value is actually going to look kind of like that. It's kind of weird in this problem. So I'm kind of getting a little bit more, I'm trying to focus on the graphical approach, and this problem is really not helping with the graphical approach, basically how it's looking, because they both meet at this point. But basically the way to do a problem like this, I'll just kind of get to the point here now because the graphing is really not helping out my explanation. So basically what you want to do is, the limit is saying what is the value of f of x as x is approaching 1/2, okay? So it kind of looks a little odd here because, or at least let's delete this here. Because we want to see as the graph is approaching 1/2 from the left as well as from the right, okay? Now, you can see though, actually, never mind, that actually works here. So we can see that at 1/2, so when I plug in 1/2 into both these equations, you can see that they both equal the value of 2, right? Now this function is actually defined at 1/2, where this one is not defined at 1/2, but it doesn't matter. It's kind of like having, so let me actually kind of draw it a little bit bigger like here. So here's 1, here's like 1/2, here's 1, 2. So we have this open circle, right? Because that's what that graph, there's the reciprocal function. And then what we have over here is this graph kind of looking like this. So this graph, this is the reciprocal port function. It's only for x values that are less than 1/2, right? So that's going to be going to the left. Sorry. Okay, because this is important to kind of understand, and I'm glad actually I went back through it. And then the vertical function actually starts, it fills in, right? Because it goes from here, it fills in, and then it goes up from there. But we don't need to include anything to the left because it said for only x values greater than or equal to. So here's kind of like a zoomed in approach of what I was trying to show. The important thing is the general limit only exists is when the function is approaching the same y value from the left and from the right. So even though this value is undefined at 1/2, you can see that it is approaching the y value of 2. Whereas also when you plug in 1/2, it's approaching the y 1/2 into the other function. You can see it's also approaching 1/2. So therefore the limit as x approaches 1/2 of the function f of x is equal to 1/2. So basically what we want to do is we want to plug in that value. We want to do direct substitution into both of those functions to make sure that they are approaching the same value. If they are not approaching the same value, then the limit would not exist, okay? But again, the limit is not looking for the value of the function. We're looking for where the graph is approaching. And for the general limit, it needs, for both of those, or needs to approach that value from the left and from the right.